Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. You gaze into the night sky, and what greets you is silence, stillness, a vast black expanse stitched with steady points of light. The stars seem unmoving, ancient, settled into a quiet cosmic order. If you lie on your back beneath that sky long enough, you begin to feel it, a sense of scale that makes time pause and thought dissolve. It feels like nothing is happening out there. It's just the quiet rhythm of celestial rest, but stillness in the universe. It's a kind of story we tell ourselves, because beneath that seeming calm, beneath the surface of every star, every planet, every patch of black between galaxies, something else is moving, something constant, something wild. It begins not with stars or even atoms. It begins with the very idea of space itself, the backdrop, the canvas, the silence between things. You've been told space is empty, that the vacuum is void, that when no particles are present, there is simply nothing. But the truth is softer, stranger, and more alive in the smallest places, far smaller than atoms, smaller than quarks, smaller than anything you can touch or measure. The vacuum itself begins to shimmer. Space fidgets, it flickers, it doesn't sit still. This isn't a poetic metaphor. This is physics down at the Planck scale, where distances are 100 billion times smaller than the width of a proton. Space behaves less like a void and more like a storm. It bubbles, it foams, it fizzes. This is the world of quantum foam. And it may be the most restless sea that has ever existed. A sea not of water, but of pure uncertainty. Even when you take all matter away, when you cool everything down, when you remove every trace of light and heat, even then, the vacuum refuses to stay quiet. It becomes a dance of brief, unpredictable appearances. Particles rise from nowhere and vanish again in a blink. Fields tremble without cause. Energy pulses into being and fades without warning. It is as though reality forgets, moment to moment, what is supposed to be and keeps rewriting itself in whispers. You don't see this with your eyes. You don't feel it in your skin. Scale is too small, the speed too fast, the energy too slight. But everything you are, your body, your thoughts, your breath floats on top of this fidgeting sea. Your life is made of atoms, and those atoms are made of particles. And those particles are shaped by rules born in the foam. The stillness that you trust, the feeling that your floor, your bed, your sky is not moving is a gentle illusion, a simplification. Even now, as you lie still, as your chest rises and falls with soft, slow breath, the atoms in your skin are shaking. The electrons around your nerves are vibrating. The particles inside your heart are dancing a rhythm born, not of life, but of the strange behavior of empty space. This motion, this trembling, is not chaos. It is not noise. It is a pattern, written in a language the universe has always spoken. One of probabilities, fields, and fluctuation. Physicists don't call this foam to be poetic. They call it that because the images demand it. At this scale, equations predict a restless churning, as if the fabric of space is made of countless tiny bubbles, constantly popping in and out of existence. Not real bubbles, of course, not spheres of soap or air, but mathematical fluctuations of energy and shape, kind of quantum fizz. And though we cannot see them directly, we feel their influence in the world above, in tiny shifts in atomic clocks, in patterns of light from distant quasars, in the slow decay of radioactive atoms. These are not random, but quietly guided by the invisible hand of the foam. In 1948, A Dutch physicist named Hendrik Casimir proposed an experiment that made this hidden motion real. He placed two metal plates close together, so close that light itself could barely fit between them, and found that they would gently pull toward each other, not because of magnetism, not because of heat, but because the vacuum between them was less empty. The quantum foam, squeezed by the plates, offered fewer ways for energy to ripple. Outside the plates, the foam danced freely. Inside, it was constrained. That imbalance, that difference in vacuum energy, caused a push, a real force, from the emptiness itself. This is called the Casimir effect, and it is one of the few windows we have into the trembling vacuum. It is soft, it is delicate, but it is measurable, okay? And it is a whisper from the foam. But what does this mean for you, lying quietly in your room, listening as your thoughts begin to slow? It means the universe is never truly still, even when everything seems settled. Your life, your room, the stars above, something beneath it all is still moving. And more than that, the universe was built on that motion. Quantum foam is not an afterthought. It is not a flaw or a bug in reality. It may be the very source of all structure, a kind of fluctuating foundation from which time, space, and matter rise, not as certainties, but as persistent habits. The stillness you feel now in this quiet moment of night is not the absence of motion. It is a kind of balance, a truce between many restless forces. It is the outward calm of something deeply, endlessly in motion. If you could zoom in far enough, not with a microscope, but with imagination, if you could shrink yourself down past molecules, atoms, nuclei, quarks, past everything we have ever seen, you would arrive at a horizon where measurement itself falls apart, a place where coordinates dissolve, where space and time lose their shape, where there are no paths, only probabilities, no objects, only blur. This is the quantum foam. It doesn't roar, it doesn't shine, doesn't break the silence, but it is always there, waiting, writing, rewriting. The universe does not need something to be happening in order to be alive. Sometimes aliveness is made of flickers, of pauses, of things that almost happen, but dawn, single quotes, and maybe that's true of you, too. Even as you slow down tonight, even as your body drifts into sleep, a part of you is still dancing. The stillness isn't still, and now, if space itself fizzes with energy, if even the most silent places tremble with possibility, then what is this foam made of? What is quantum foam, really? And why does the universe need it at all? Let's drift there next. Take a deep breath. Now imagine shrinking slower than thought, smaller than imagination, down past skin and blood, past the atoms in your bones. Drift through protons, through quarks, through the last known particles. Keep falling, keep folding, into something even less solid than solid. Eventually, you pass beyond the known, and there, in the smallest corners of reality, you find it. Not a place, but a behavior. Not a surface, but a texture in the fabric of existence. Quantum foam. The name sounds soft, like sea bubbles clinging to the shore, like the last fizz in a glass. But what it describes is the most restless, least understood aspect of the universe. A chaos so quiet it fills even silence. A turbulence so small it touches everything without ever being felt. It begins at the Planck scale, the smallest scale, at which our current theories believe space and time still make sense. Okay, to understand quantum foam, you must first understand what a Planck length means. Roughly 1.6 x 10 to 35 meters. That's a zero, followed by 34 more zeros and A1. This is not merely small. It's unimaginably beyond microscopic. It's 100 million trillion times smaller than the nucleus of an atom at this scale. Reality stops behaving like anything familiar. You can't speak a position the way you do on a map. Q can't speak of time as something that ticks forward in even rhythm. What emerges instead is a universe where everything trembles with possibility, where particles, fields, and even geometry behave less like objects, okay, and more like probabilities. In this realm, the very fabric of space isn't flat or smooth. It's bumpy, lumpy, constantly shifting, like boiling water. Only the bubbles are fluctuations in energy itself. So what is quantum foam? Physicist John Wheeler coined the term in the 1950s, trying to imagine what spacetime would look like at the Planck scale. In general relativity, spacetime is smooth and curved by mass, like a trampoline sagging under a bowling ball. But quantum mechanics demands uncertainty, constant motion, randomness. Wheeler wondered, what if, at the tiniest level, space-time wasn't smooth at all? What if it was a restless storm of tiny fluctuations, energy appearing and disappearing, space curling into microloops and vanishing again? Not a grid, not a void, but a foam. This foam, then, is the bubbling texture of space itself, an ocean of quantum uncertainty, where empty space is anything but. Even in the absence of matter or light, space is not still. It's in constant flux, as energy briefly exists and then fades. These fluctuations are predicted by the mathematics of quantum field theory. They're called vacuum fluctuations, and they happen because the uncertainty principle says that if you try to know the energy of a region perfectly, you lose all knowledge of when that energy appears. So energy comes and goes. It blinks into being. It leaves tiny echoes. Some of these echoes can be measured in the shifts of energy levels inside atoms, in the behavior of light traveling near powerful magnets, in the Casimir effect between two metal plates in a vacuum. But quantum foam itself, as a whole, is too small to see, too chaotic, too tame, too subtle to catch directly. It is a hypothesis, a dream woven by mathematics, okay? When yet, without it, the rest of the universe makes less sense. Think of it this way. You're floating in space. You look around, there is nothing, just vacuum. But in the vacuum, particles are popping in and out of existence. Tiny pairs, a particle and its opposite, born from energy and then gone in a breath. They're not stable, stand. They're not even real in the everyday sense. They're virtual particles, quantum possibilities, pouring energy from the vacuum, so long as they repay the debt almost instantly. This buzzing ocean of virtual particles contributes to something real, the zero-point energy of space, the lowest possible energy that a quantum system can have, even at absolute zero, even when everything else is removed. This energy remains. This is not just theory. The consequences of this energy ripple outward into cosmology, particle physics, and even gravity. Some physicists believe that dark energy, the force that causes the universe to expand faster and faster, may be related to this vacuum energy, this frothing foam. Others suspect that the true theory of quantum gravity, the holy grail of physics, will emerge from a deeper understanding of quantum foam itself. Because here's the tension. We have two great theories. Quantum mechanics describes the small, general. Relativity describes the large. But when you try to apply both at the same time, say, to a black hole, or to the first moment of the Big Bang, the math breaks. The two theories clash. The universe gets confused. And in the middle of that confusion, at the boundary where both theories must meet, lies quantum foam. It may be that space and time themselves are emergent, not fundamental ingredients of the universe, but something built from deeper rules. Like temperature is not a thing in itself, but the average of a million moving molecules. Perhaps space is the same, just the average effect of countless foam-like fluctuations. What would that mean? It would mean you're not moving through space. You're moving on top of a sea of tiny changes, that your every breath, every thought, every step plays out not on a silent stage, but on a restless, shimmering field of creation. And though this field cannot be touched, its presence is felt everywhere. Your body, for example, is not made only of atoms. It is made of interactions, forces, energies, probabilities. Every chemical bond, every electrical signal in your nerves is made possible by the quantum fields that emerge from this foam. And if you could pause the universe, freeze it in time, look closely enough, far below what eyes can see, or even what instruments can measure, you might not find space at all. You might find only activity, only shimmer, only bubbles of maybe what happens in these bubbles. We don't fully know. It's possible they curve space locally. They might, momentarily, birth tiny black holes that collapse in an instant. They might cause energy to warp into brief loops or even wormholes. Some theories of quantum gravity, like loop quantum gravity, attempt to describe space-time as made of discrete chunks, linked like a fabric. Others, like string theory, suggest the foam hides vibrating strands that define everything in the cosmos. No one theory is complete, but they all agree on this. What we call empty is far from it, and so the foam becomes a symbol, a threshold, a mystery. When you lie in bed at night, drifting into sleep, it may seem as though everything slows. Thoughts become softer, senses dull, the body surrenders, but beneath that stillness, you float atop a world that never stops moving. Quantum foam does not sleep. It flickers, it breathes, it dreams in math, and in its gentle turbulence may lie the answers to every question we haven't yet learned how to ask. So now, if the vacuum bubbles, if nothingness flickers with fleeting energy, what does that mean for time? Can time itself be caught in the foam? Could time foam? Could a moment ripple? Let's drift there next. Close your eyes. Picture silence. Not the silence of a quiet room or a sleeping forest, but a silence so complete it seems to cradle the universe. The silence between stars, the stillness between atoms, the nothingness beneath all things. Now, imagine that even this silence breathes, because in quantum mechanics, nothing is not what it seems. In our everyday world, emptiness is absence. An empty room is one without people. An empty box is one without contents. But in the quantum world, emptiness teams with motion. Absence is not stillness, it is potential. Welcome to the strange reality where nothing becomes something. This is not poetry, it's physics. Real, testable, measurable physics begins with a simple, unsettling truth. A vacuum is not truly empty. According to quantum field theory, even the most perfect vacuum is alive with activity. It may appear still, but hidden beneath that stillness is a restless, flickering ocean of energy. Fields extend through space, everywhere, all the time. These fields are not always active, but they are never gone. And within them, particles, virtual particles, can appear spontaneously. No cause, no warning, just a flicker. One moment there is no particle, the next moment there it is. And just as quickly, it's gone. This is known as a vacuum fluctuation. Imagine you are floating in deep, dark space. There are no stars, no planets, no light, nothing. And then a tiny burst, pair of particles emerges from the vacuum. A particle and its antiparticle, drift apart, last a fraction of a moment, and then annihilate each other, vanishing back into the nothing they came from. This isn't a trick of the mind or a metaphor. It is something we have observed, not directly, but through its effects. One of the clearest examples is the Casimir effect. Two uncharged metal plates, placed extremely close together in a vacuum, are mysteriously drawn toward each other. There's no force between them, no particles, no radiation, and yet they move. Why? Because the space between them allows fewer vacuum fluctuations than the space outside. The difference creates a gentle pressure, a whisper from the quantum sea. And so, in silence, the plates drift. This might sound like an exotic curiosity, but vacuum fluctuations affect everything from the way atoms behave to the very fabric of the cosmos. Even the stability of matter depends on them. The electron's energy levels in a hydrogen atom, for instance, are slightly shifted because of interactions with virtual particles blinking into and out of existence. But what are these particles? Physicists call them virtual, not because they are fake, but because they are temporary. They cannot be directly observed or isolated. They don't live long enough to be measured like normal particles, but they affect outcomes. They leave fingerprints on energy. They are born from the uncertainty principle, that rule which says you cannot know everything at once. In the quantum world, you can't perfectly know a particle's position and momentum. You can't perfectly know a field's energy and the time that energy lasts. This fuzziness, this built-in uncertainty, makes room for surprises, okay? And in that room, something happens. Nothing becomes something. Think of it this way. Imagine a still pond, flat, silent, but under the surface, countless small fish dart back and forth, unseen. The surface looks calm, but it is alive. Quantum fields are that pond. Virtual particles are the fish. The foam of spacetime is the place where the fish sometimes leap. Now extend this further into the beginnings of time. Some physicists believe that vacuum fluctuations may have played a role in the birth of the universe itself. In a model known as inflation, the early universe underwent a rapid expansion, growing from subatomic to cosmic size in a fraction of a second. And what fueled this expansion? Not particles, not stars, but energy trapped in empty space, a form of vacuum energy. This energy wasn't nothing. It was everything. It pushed space outward, stretched it, shaped it, and then perhaps fluctuation occurred. A ripple, a quantum flicker, and from that flicker, structure began. Matter congealed, light scattered. Galaxies spun into being. In this view, the entire observable universe was seeded by a momentary tremble in nothingness. A particle from a void. A fire from foam dot. Now, in the present day, echoes of these fluctuations continue to ripple through time. The cosmic microwave background, faint afterglow of the Big Bang carries tiny variations in temperature. These variations, measured in millionths of a degree, reflect quantum fluctuations stretched across the sky during inflation. In other words, the galaxies, you see the stars, the planets, even the atoms in your body may owe their existence to fluctuations in what we once thought was nothing. And there's more. Some physicists wonder if fluctuations can spark matter. Could they also spark entire universes? In some theories, especially those involving eternal inflation in the multiverse, regions of space undergo different fluctuations. Some regions collapse, others expand. Fluctuation large enough for air, but possible, might birth a whole new bubble of space-time, a universe with its own physics, its own constants, its own galaxies, maybe even its own version of you, all from a moment where nothing decided to blink. So, when we say nothing, we must be careful, because in the language of quantum physics, nothing is a field. It is a potential. It is a canvas that paints itself. It holds all that could be. It hums with the memory of what might have been, and the whisper of what might yet be. Now, take this idea to the personal level. The air around you, seemingly empty, is not empty. The space between your fingers, your neurons, your thoughts, not empty. Virtual particles dance in your room right now. They dance under your bed. Hey, pulse inside the atoms of your chest. And though they vanish too quickly to leave a mark, they are part of the engine that keeps your body alive. Your heartbeat, your brain waves, your breath, all balanced on a sea of unseen becoming. You rest, but the foam beneath you does not. You sleep, but nothing ever fully sleeps. And maybe that's comforting, to know that even in the darkest, most silent places, where there is no light, no warmth, no memory, something is always happening. A flicker, a spark, a maybe. Now close your eyes again. Feel the stillness around you. No, it's not still. The vacuum fizzes, the nothing dreams, and the next time you think of silence, remember, it may be the loudest thing you'll never hear. So what happens at the very edge of this flickering space? Okay, where does measurement fail? Okay, where does space begin to forget how to be space? We are heading there next, to the boundary, where knowing breaks down the Planck length. Planck length. You measure the world to feel anchored, a footstep, a second, a breath, a grain of sand held between your fingers. Numbers give you shape, certainty, a way to say, this is here. This is real. We measure to make sense. We divide, compare, and name. But at some point, measurement falters. Not because we lack tools, but because the universe itself begins to blur. Welcome to the Planck length. It is not a place. It's not a thing you can see or hold or point to in space. It is a threshold, a line drawn not in sand, but in understanding. And beyond that line, reality no longer behaves as you expect. The Planck length is unimaginably small, about 1.616 x 10 meters. Take the width of a human hair, divide it by 1,000, then divide that by 1,000,000,000,000, then divide again and again, okay? You will still not be close. At this scale, size itself becomes a slippery concept. You might ask, why should such a tiny length matter? Because at this scale, space as we know it dissolves into uncertainty. Imagine looking closely at a smooth surface, perhaps a polished wooden table. From a distance, it's flawless. But get close, and the grain reveals itself. Closer still, and you see splinters. Zoom in further, and the wood becomes atoms, then protons, then quarks, and beyond quarks. There's no beyond. Not in the way you think. You reach a point where space-time, what you've always believed to be smooth, continuous, and absolute, becomes grainy, frothy, and unstable. This is the quantum foam, and the Planck length marks the edge of its rippling sea in mathematics. The Planck length arises naturally from the constants of nature, the speed of light, how fast information travels. Planck's constant, the graininess of energy at small scales, Newton's gravitational constant. The pull between masses, combine them, and you get a number that suggests a limit, not a physical wall, but a breakdown in meaning. At distances smaller than the Planck length, we can no longer trust our equations. Space becomes too unstable, too uncertain. Attempts to measure position or time at that scale inject so much energy, they create disturbances large enough to warp space itself. Try to shine light to probe something smaller than the Planck length, and the energy of that light may collapse into a black hole. In other words, the act of looking tears the thing apart. So, physicists tread carefully here. They call the Planck length a fundamental limita, barrier, built not of stone or space, but of logic. Some believe that beyond it lies a world, not of particles and waves, but of raw information, pixels of reality, woven into a cosmic code. Think of it this way. If the universe were a digital screen, the Planck length might be its pixel size. Everything you see, feel, or imagine compressed into the flickering arrangement of these fundamental bits. Not smaller, not smoother, just now, let's bring this closer. Your body is made of atoms. Each atom, a world of orbiting electrons and nested particles. Zoom into one of your cells, into the carbon that gives you structure, into the protons within, and down, until you reach a point where asking where or when no longer makes sense. This is not an end. It is a transformation. Reality doesn't disappear at the Planck scale. It transforms into something else. A field, a probability, a cloud of possibility. Where once was a place, now only uncertainty. And still, the universe carries on. Some physicists dream of a theory of quantum gravity, model that unites Einstein's gentle curves with quantum mechanics' restless twitching. They imagine loops of space, tiny vibrating strings, or networks of spin and twist. All of them seek to explain how the smooth river of relativity gives way to the granular churn of quantum foam. But no one knows for sure. We can't peer directly into the Planck world. Not yet. Our instruments aren't fine enough. Our equations still argue. So we listen to its echo instead, in black holes, in cosmic background radiation, in the faint fuzziness of particles, in time. The Planck length has even shaped your universe's birth. In the very first instance of the Big Bang, when the entire cosmos, smaller than a grain of dust, space itself surged with unimaginable energy. Everything you now see was once compressed into a foam of Planck-scale fury. Time may not have ticked in those moments. Cause and effect may have blurred. Space may not have floated, may have sputtered, blinked, stretched sideways, collapsed, and formed again. This early Planck era is the great unknown, a period where our science falls silent, not from lack of effort, but from reaching the edge of what meaning can measure. And yet, the legacy of this moment remains in you. Every heartbeat, every breath, every atom in your bones is born from a scale beyond knowing. So what does this mean for you, lying still in bed, drifting toward sleep? It means that beneath the world, beneath all comfort and structure, there is a sea of questions so small they cannot be asked with words. A space too soft for measuring tape, time too jumbled for clocks, only rhythms, pulses, flickers, and perhaps that is why you sleep. To drift into a state where logic loosens, where lines blur, where dreams begin to touch the Planck world, not as answers, but as quiet, trembling questions. So rest now, let your breath rise and fall like the surface of a deeper sea. Let the boundaries of your thoughts soften. Let measurement give way to mystery, because beyond your knowing, beneath your silence, the quantum foam waits, not for answers, but for attention. And now that we have glimpsed the smallest edge of space, what happens to time in such a place? Time, too, begins to fidget, twofold, to dance in bubbles of its own. Let's follow it there. You've always known time as a river. It flows in one direction, from past to present to future. You mark it with clocks, calendars, memories. You feel it in the growth of your body, in the fading of light, in the rhythm of sleep. Time feels solid, inevitable, continuous. But step into the quantum foam and time becomes strange. Down at the Planck scale, beneath atoms, beneath energy, beneath the very space your thoughts float through. Time does not behave. It does not tick. It stutters. It loops. It bubbles. Imagine looking at the surface of water in slow motion. You see bubbles form, rise, and burst. Now, imagine time itself doing that, flickering into being, disappearing again, swelling forward, folding back. This is not imagination. This is a serious possibility in modern physics at the scale of the quantum foam. Time may not be a flowing stream, but a chaotic sea of foam, full of eddies and whirlpools, and your thoughts, your actions, your body exists because of its larger rhythms. But below, deeper, in the smallest spaces, time may not even exist at all. There are equations deep within quantum gravity that describe a world without time. Not because it has stopped, but because, at those scales, time is not fundamental. It is emergent. That is, time might not be something the universe starts with. It might be something that forms later, like clouds condensing from vapor into foam. Before time, there may only be change. Not change across a timeline, but change is pure difference. One quantum field, then another. One bubble, then a ripple. Not in sequence, but in shimmering possibility. Think of a melody, you know? Its notes follow a certain rhythm. But take that music, shuffle the notes, play them all at once, okay? Overlay them, and the melody vanishes at the Planck scale. Time might behave this way. No, before or after, quote, only all at once. Some physicists call this the problem of time, because time appears in general relativity, Einstein's smooth theory of gravity, but it disappears in the quantum world. In relativity, time bends around stars. It stretches when you move fast. It slows near massive planets. It warps, twists, but still flows. But in quantum mechanics, when you look deep enough, time vanishes. There are models where all of space and time is encoded in a timeless state. And what we experience as time is simply our minds moving through patterns, like a book already written. And you are reading one page at a time, or like a movie. Real every frame exists at once, but you experience the story by watching them in order. You might ask, if time doesn't exist at the deepest level, how can I age? How can my tea cool? How do we speak, grow, die? And the answer may be this, because at larger scales, time emerges. It is not made of seconds, but of entanglement, of thermodynamics, of information at the macroscalar world. Your body, the arrow of time, is tied to entropy. Entropy is the measure of disorder. You crack an egg, high entropy. You drop a glass, it shatters. Things tend toward disorder. And that march creates the feeling of time. But in a quantum foam, before entropy, before temperature, before particles settle into matter, there may be no direction at all. Time may be symmetrical. Forward and backward become the same, and yet, here you are, feeling the now, breathing in sequence. Remembering a past, imagining a future. How does this fragile structure of time rise from the chaos? Some believe it's all about perspective, that our minds, rooted in biological rhythms, create time by the way we process change. Your brain does not sense time directly. It strings moments together through memory. It compares the rate of change across sensations, your heartbeat, other, blinking, your breath. These metronomes make you feel time passing, but remove them, float in space, in silence, in sensory stillness, and time can unravel. Astronauts report this. Dreamers report this. You felt it too, in deep sleep or illness, when hours vanish or stretch endlessly. This suggests that time is not a constant beat, but a perceptual rhythm, and the foam beneath you, it hums with its own silent tempo. Some models propose that time bubbles up from quantum entanglement, that particles connected across space give rise to sequence, a kind of choreography of possibility that defines before and after. Others see time as a thermodynamic illusion, an arrow that only exists because energy spreads, because heat flows from hot to cold. In both ideas, time is not a background. It is a behavior, a pattern, and patterns, like waves, like music, need context. Zoom in too close, and the rhythm disappears. All of this suggests something strange, that what you call the present moment may not be a slice of time at all, but a construction, composite of memory, sensation, and anticipation, a bubble of now, drifting in a sea of timeless quantum foam. This has implications for everything, for the Big Bang, for black holes, for consciousness. There are ideas that time may not exist inside black holes, that past and future collapse into a single, timeless state. There are theories where the entire universe is static, and your experience of flow is just movement across slices of a higher dimensional shape. This is dizzying, but not frightening, because you are still here, still breathing, still counting the seconds, even if the universe doesn't. And perhaps, as you drift off to sleep, that is enough. Let your thoughts untangle. Let your heart beat slow. Let the clock dissolve, because even without time, Change still happens in foam, in dreams, in memory, and somewhere beyond these floating bubbles of time lie strange spaces of curvature and force, places where space-time itself bends, where bubbles curve, where dimension wobbles like jelly. Let's go there next. There's a quiet kind of chaos that lives beneath everything. Not the loud chaos of accidents or noise, not the chaos of emotion or sudden change. This is the chaos of shape, of form, of subtle tension. You're used to thinking of space as a container, a soft, empty stage on which events unfold. Okay? Left, right, forward, back. You move through it like a swimmer through water, trusting its stillness. But beneath that stillness, the fabric of space is not flat. It is not smooth. It curves. It folds. It breathes. And at the smallest scale imaginable, inside the strange haze of quantum foam, this fabric bubbles, not with air or vapor, but with distortion. Each bubble, a pocket of space-time pushed outward, or pulled inward, each curve, a wrinkle in reality. If you could shrink yourself, not to the size of a cell or an atom, but trillions of times smaller, down to the Planck length, you might find yourself adrift in a sea of tiny warps, in folds, little hills of gravity, little dips of expansion, a froth of space itself, endlessly shifting. These are not metaphors. This is the language of quantum gravity. Physicists believe that at these scales, space-time is not continuous, but quantized. Just as light is made of photons, space-time might be made of discrete units, tiny loops, strings, or nodes, woven together like a cosmic fabric. And when these loops tangle, when they vibrate, when they interact, they create curvature. Each fluctuation becomes a tiny gravitational field, a miniature well or peak of distortion. You live in a universe sculpted by this curvature. It's how planets orbit, how time slows near a black hole, it's how your feet feel heavier than your hair. And in the foam, this sculpting happens constantly, but on a microscopic, jittery scale, so small, so fast, so delicate, that it all blurs into silence. Imagine a trampoline, dotted with dew. Each droplet weighs almost nothing, but bends the fabric slightly. Now imagine trillions of droplets dancing on a trampoline made of fog. That's quantum foam. Each droplet bends space-time for a blink, then disappears. Then another appears, a chaos of bubbles, warping geometry like breath on glass. And you are here, walking, breathing, dreaming on top of it all. This bubbling might even be the source of mass. Some theories propose that the reason particles weigh anything at all is because they interact with this foaming field, like boats struggling through choppy waters, and it goes deeper still. This bubbling may give birth to gravity itself. Einstein described gravity as the curvature of space-time, a smooth, elegant bend caused by massive objects. But some physicists now ask, what if gravity doesn't come from mass pulling on space, but from space pushing back? It's from foam expanding and recoiling, curving in response to vacuum energy, to the jostling of particles. In this view, gravity is not a fundamental force. It's an emergent phenomenon, like the waves you see on an ocean surface, formed by countless collisions beneath dot and so. Gravity becomes a story about collective behavior, just as temperature is not found in one molecule, but in the dance of many. Gravity might rise from the chaotic ballet of space-time bubbles. This isn't settled science. It's a quiet theory, whispered in labs and chalkboards. But it's beautiful because it suggests that the largest force you know, the one that holds galaxies together, okay, that shapes planets, stars, okay, even time, might come from the smallest tremors in the universe. A symphony of trembles, a ballet of curvature, a sea of bubbles, shaping reality. Let's linger here for a moment longer. Picture space as a sheet stretched in all directions. You place mass on a TA planet, a person it sinks. Other things roll toward it. This is classic relativity. Now imagine if that sheet wasn't smooth, but fizzy, covered in bubbles, each bubble shifting the slope slightly, making the terrain uneven, dynamic, responsive. Particles don't just move through this space, they interact with it. They are affected by the foams, jiggle, their paths bend, the speeds vary. Even the passage of time may stretch and contract as they pass through these micro-curvatures. There's no such thing as a perfect vacuum. What you call empty space is never empty. It hums, stirs, it curves and uncurls. And yet, all of this happens invisibly. No telescope can see these bubbles. No microscope can trace them. They are too small, too fast, too uncertain, but we feel their influence in subtle ways, in the way particles decay, in the way light bends near stars, in the way clocks tick more slowly in orbit. These are shadows cast by the foam, echoes of a deeper rhythm. You live on a planet which orbits a star, which floats in a galaxy, which drifts through curved spacetime, and beneath all of that, beneath the atoms in your body, beneath the forces that hold them together, beneath the silence you hear when the world is quiet, there is foam, not just a metaphor, a field, a texture, a trembling, and this trembling may be the scaffolding on which all of reality is built. So the next time you feel stillness, remember, the stillness is folded, layered, bent. You are floating, always, an invisible geometry, a lattice of loops and curves and possibility. And as this foam bubbles, particles pop into being. Mass finds its meaning. Its gravity rises like morning fog. Even the shape of the universe's curves, its angles, its expansion may be traced back to these tiny, trembling bubbles. So now, as your breath slows, as the night folds around you, as your thoughts drift like satellites in the dark, know this: you are a child of curvature. It's a traveler on warped terrain, an echo of foam's restless dream. And in that dream, something else is forming, not a shape, but a flicker, a presence, a whisper from the vacuum itself. Shall we follow it? Let's listen for the voice of something stranger still. Particles that flicker without mass, fields that tremble without source, energy that rises from nothing. Let's go there next. Imagine two old friends, both brilliant, both stubborn, trying to describe the same landscape from two different mountaintops. One sees curves, the other sees chaos. The first is Einstein. He speaks in geometry. Tam, the universe is a smooth, elegant fabric. Mass bends space. Space tells time how to tick, and gravity is just the path things follow when the map is warped. He draws clean lines, calculates precise orbits, imagines clocks on rockets and light bending near stars. His universe is majestic and predictable, like the slow arc of planets across the sky. But then there's the second voice, the whispering one. It's the voice of quantum mechanics. This voice doesn't deal in curves, it deals in clouds, probabilities, fluctuations. It says, a particle doesn't follow a clean path. It jitters. It exists here, and also over there. It has a position, but not exactly. It has momentum, but never both with certainty. Where Einstein offers a map, quantum physics offers fog. Particles' world is fuzzy and uncertain, as if the universe is making up its mind only after you look. And here is the strange part. Both are correct. Relativity explains the cosmos on a grand scale, the motion of galaxies, the ticking of satellites, the way time bends near a black hole. Quantum mechanics explains the tiniest threads, the behavior of electrons, the bonds of atoms, the way particles tunnel and twirl and blink. But these two visions, so clear in their own realms, do not fit together. Try to stitch them side by side, and the math breaks. The predictions dissolve. The laws refuse to shake hands, and nowhere is this mismatch more obvious than inside quantum foam, because in that realm so tiny, so fleeting, so mysterious, both theories must apply. Einstein's curves meet quantum's tremble. Geometry meets uncertainty, and something extraordinary begins to happen. Space, which Einstein says should be smooth, becomes jagged and frothy. Time, which should march forward steadily, jumps and loops in tiny fits. Here, uncertainty reigns. Heisenberg's principle whispers, you can't know a particle's position and momentum exactly. The more you know of one, the less you know of the other. So, the very curves of space-time, which in relativity are calm and continuous, now flicker, dance, and blur. Imagine a road that changes shape just because you try to walk on it. A surface that shifts beneath your feet each time you take a step. This is the realm we enter. Einstein's gravity tells us how things should fall. Quantum mechanics tells us how things shimmer, but gravity pulls things toward the center. Quantum physics pushes them out, insisting that even emptiness must vibrate with potential. This clash, this tension between the smooth and the uncertain, is one of the deepest puzzles in science. It's called the problem of quantum gravity. Physicists have spent decades trying to unite the two, to build a bridge between the curve and the chaos. Some build with loops, tiny links of space and time. Some weave with strings, vibrating threads that hum in extra dimensions. Some use equations like sculptors, chiseling reality from math. But the foam, for now, remains mysterious. And yet, it offers hope, because in that bubbling, shittering sea, we see hints that the universe may not be divided after all. Perhaps space is not continuous, as Einstein believed, but made of tiny chunks. Perhaps time is not a line, but a cascade of quantum choices. And maybe, just maybe, gravity doesn't pull. It emerges. It rises from the dance of tiny uncertainties, like a song built from whispers. This is more than philosophy. It affects how we understand everything, from the birth of the cosmos to the edge of a black hole. Take black holes, for example. Stein tells us they are pure geometry, a place where space-time curves so sharply that not even light can escape. But quantum mechanics says, wait, nothing is absolute. Even black holes must leak, bit by bit, through radiation. This idea, Hawking radiation, was born from trying to force Einstein and quantum theory to speak. And in that conversation, we saw something new. That information, perhaps, is never truly lost. That black holes may not be eternal prisons, but engines of transformation. And if that is true, then maybe the foam isn't just noise. Maybe it's a language, a code, script written in the smallest letters, telling the largest stories. And if space has texture, if time has rhythm, then you are not separate from them. You are written in this same language. Your atoms obey these same strange rules. Your thoughts, yes, even now, flicker through a brain made of particles, through neurons that tunnel and fire with quantum quirks. You, too, are a meeting place between Einstein's smooth and quantum's. Restless, your dreams move like waves, but your body rests in gravity's arms. You are both the stone and the ripple, the curve and the shimmer. And maybe, just maybe, your awareness is what holds them together. Because there's something else hidden in the clash, the role of the observer. Quantum mechanics tells us that nothing becomes real until it's measured, observed, touched by awareness. Before that, it remains a maybe, a cloud of probability, a soft hum of potential. And so the question arises, are you shaping the foam just by being here? Are you part of the dance that weaves curve into shimmer? Some physicists think so, that the act of observing is not a passive thing, it's creative, defines what is. When you look at a particle, you don't just see it, you make it be there. You settle the wave. You collapse the possibility. And if that is true, then perhaps the very fabric of the universe, this strange, flickering foam, is not something outside you, It is something you participate in just by thinking, by breathing. So, tonight, as your mind slows, as your body drifts, space becomes soft and time becomes warm. Remember this? You are the quiet meeting of two great truths: the elegance of Einstein, the mystery of the quantum dot, and beneath your pillow, beneath the floor, beneath the stars, the foam continues to shimmer, waiting, as always, to become something new when the next thought arrives. And in the silence that follows, the thread is tugging, invisible, instant, entangled. Something else awaits. Somewhere in the hush between seconds, a thread stretches across space. Not a rope you can see, not a wire you can tug, but a connection so intimate, so absolute, that it ignores distance altogether. This is quantum entanglement. Two particles, let's say electrons, born together or interacting just once, can become entangled. A single breath, moment's closeness, and something invisible links them forever. They could be separated by miles, by oceans, by galaxies, but measure once, just gently observe it, and the other responds, not with delay, not after a pause, instantly, as if the space between them wasn't there at all. It sounds like magic, but it isn't. It's quantum physics, and it's been proven again and again. Let's slow this down. Imagine you have two coins, each sealed in its own box. You spin them together, then separate the boxes, one to your room, okay, and one to a friend across the world. Now, neither of you opens the box. You wait until finally you lift the lid. Heads, instantly, your friend opens theirs. Tails, and this happens every time. Opposite, linked, except with real particles. It's not chance. It's law. The spin, the polarization, the quantum state. These are decided until one is measured, and in that instant, the other becomes real. To tau. Einstein called it spooky action at a distance. T didn't like it. It seemed to violate his idea that nothing, not even information, can travel faster than light. But experiments say otherwise. We've entangled photons and sent them from mountains to cities, from satellites to stations, and still no matter. The stretch, they behave like mirrors of one another. But is it faster than light? No, because no message can be sent that way. You can't use entanglement to whisper a secret to someone on the moon. It's not communication, it's correlation. A shared script written before the show begins. Still, it changes how we see the universe. Because in this realm, distance isn't a barrier, It's a story we tell ourselves based on classical thinking. Entanglement says, what matters isn't where, it's how deeply something is connected. The fabric of space may stretch, but entanglement stitches through it as if two particles are pages of the same book, no matter how far apart those pages fall. And it's not just particles. Atoms can be entangled, molecules, even entire clouds of gas, and soon, perhaps, systems large enough to see, maybe even memories, maybe even choices. Because the deeper question is this: what else is entangled? Could you, sitting still in your bed, be linked to something distant, to a moment long past, to someone not yet met? Science hasn't answered that, but it has shown that entanglement is more than curiosity. It may be the foundation of quantum computing. Ordinary computers use bits, ones and zeros, but quantum bits, qubits, use entanglement to exist in combinations, superpositions, layers of possibility. An entangled computer doesn't just check one solution. It explores all paths at once, then collapses into the best. This is computation that hums in parallel, like dreaming logic. An entanglement helps with encryption. 2. Quantum key distribution, a way to share secrets so secure that any eavesdropper destroys the message just by looking. It's a kind of trust built into the rules of the universe, because entanglement doesn't allow spying, only shared experience. But now, pause. Close your eyes. Feel your own body, your pulse, your thoughts, your soft breath against the quiet. You are not a photon. You are not a spinning atom. And yet your atoms were born in stars. They're particles, formed in the early universe. Some of them, perhaps, have danced with others and carry those invisible threads still. What if entanglement is not rare? What if it's everywhere? Not in ways we can measure, not yet, but woven into the bones of the world. What if consciousness is part of the entangled web? Some researchers wonder if the brain uses quantum effects, tiny molecules tuned like instruments, reacting not just to chemical cues, but to entangled states. There is no proof yet, only hints, only dreams, but it's worth pondering. When you feel someone's presence before they speak, when you think of a loved one and they call, is it just chance? Or a whisper of connection science doesn't yet know how to hear? Entanglement challenges our idea of separateness. It says, you and I are not entirely apart. We may be linked in ways our senses can't detect. A field, a thread, a quiet chord struck between two souls across a sea of stars. And, in physics, this may explain not just communication, but the very structure of reality. Some theories suggest that space itself is built from entanglement, that the bonds between particles are what holds space together, that geometry, gravity, even the stretch of dimensions emerge from this underlying connectedness. Entanglement may be the loom on which spacetime is woven. Imagine that, not emptiness between stars, but a web, not void, but relationship, a cosmos built not from things, but from how things relate. And so, when you lie down tonight, when you rest your head and drift slowly into quiet, know that the silence isn't empty, that somewhere a particle trembles in tandem with another, that even as you exhale, somewhere far beyond your breath, a response hums, not because you command it, but because it has always been with you, entangled, linked, part of the same unfolding. And if the next chapter asks whether you are a fixed thing or a shimmering possibility, remember this: you are not alone, and never were. You think of yourself as solid, skin, muscle, blood anchored to a shape. You point to your arms, your chest, you see a reflection in the glass, and you say, that's me. But look closer. Beneath your skin is a dance, not of organs and tissues, but of particles, fields, vibrations, and possibility. Because, at your core, you are not made of certainty. You are made of maybes. A proton in your fingertip does not sit in one place. It hums. It pulses between points. It exists as a wave of likelihoods, a cloud of where it could be, until it's touched, measured, seen. So too are your thoughts, your memories. They do not live in a single, fixed groove. They flicker through electric pathways, never exactly the same twice. They shimmer with context, mood, and time. You are not fixed. You are unfolding at every scale, from the smallest quantum field to the largest decision you make. You are a sum of probabilities. Let's stay with your atoms. Every one of them is a pattern, not a point. An electron around a nucleus does not orbit like a planet. It lives in a haze, a probability cloud that wraps and stretches, sometimes round, sometimes odd-shaped, but always uncertain, until you observe, until the system interacts. Then the cloud collapses, and the electron is somewhere. This happens again and again in your body. Not just once, not rarely, but constantly. You are, right now, a vast orchestra of collapsing probabilities, particles choosing paths, waves settling into notes, fields shifting in real time. It's music, not mechanical, but alive, and the conductor is no one, or maybe everything. You are not conducted, you are composed. Your thoughts arise not from solid gears, but from shimmering patterns in quantum fields. Some researchers suggest your neurons, ES, those microscopic cells, may amplify quantum effects, that choices might ripple up from the indeterminate behavior of single molecules, that when you decide to lift your hand, somewhere deep in the scaffolding of your being, a quantum flutter began it. Think of that every yes or no might begin as a superposition, a maybe, and you, this self, you feel so clearly, is the temporary resolution of all those maybes, a song from a sea of options, a harmony from the hum of potential. That doesn't mean your life is random. Far from it. It means your life is textured, subtle, nuanced, elastic, that you are not stuck in a single story. You are the probability of many stories, and each moment collapse into one, but only for a breath. Then the field reshapes. Then you shimmer again. This also means you're never alone in your choices, because even choice is part of a probability space. Not just personal, but cosmic. Your brain lives in a quantum universe. It drinks from its uncertainty. It listens to its music. Even the warmth you feel as you lie still in your bed is a kind of quantum miracle. Heat is movement, and movement is vibration. Okay. And vibration, at the smallest level, it's uncertainty, trembling through time. Your body is warm because your particles refuse to sit still, because your atoms cannot help but shimmer. So the warmth of your skin is the song of probability itself. And when you breathe that same indeterminacy. Air particles moving in chaotic paths, never quite repeating, carrying information from trees, from oceans, from the breath of others who lived before you. Every breath you take is entangled with billions of chances, and every cell it touches becomes a listener in this quiet symphony. Even your DNA, that most intimate spiral, is built from components that rely on quantum behavior, tunneling, entanglement, fluctuation. Your life, your body, is quantum, through and through. But it doesn't feel that way, does it? It feels solid, predictable, steady. That's because your senses filter the hum. They smooth out the shimmer. They give you a usable version of reality, one that lets you walk, speak, sleep. But beneath that surface, the foam still fizzes. Probabilities still weave dot. It's not a trick. It's not a glitch. It's the foundation. And you can feel it in quiet moments, in the feeling of a thought arriving before you expect it, in the strange calm that tells you something is about to happen, in the flicker of memory that seems to rise from nowhere. You are riding the probabilities, like a leaf on a pond that's always rippling, always adjusting. There's no map. There's only flow, dot, and what a beautiful thing that is, to be part of a universe that isn't fixed, but responsive, elastic, full of shimmer. And you're not just responding, you're reshaping it too, because your attention collapses waves, your observation stabilizes fields, your choices, your quiet decisions settle maybes into moments. The more you pay attention, the more you shape. That's not magic, it's participation. It means you matter, not just emotionally, but physically, scientifically. The universe is listening to where you look, to what you weigh, to when you choose to see, and in doing so, it responds. You are not a bystander. You are a note in the great composition of time and being. So rest easy, cool, knowing that your story is still being written, not in stone, but in waves, in chances, in shimmering, shifting music that only you can play. And just beyond this music, waiting quietly at the edge, is a phenomenon even stranger, where particles ignore walls, where logic bends, where thought might pass through what should be impossible. It's called quantum tunneling, and it may be closer to you than you think. Close your eyes for a moment. Now imagine standing before a stone wall, tall, dense, impossible. You walk toward it, and logic tells you to stop. It's solid, unyielding, final dot. But now, forget what logic tells you. Shrink down, smaller than atoms, smaller than electrons. Become a particle. And now, walk again. What was a wall begins to shimmer. It pulses with possibility. You step forward and you pass through. This is not a dream. This is quantum tunneling at the smallest scales. Barriers aren't always barriers. They are suggestions, not absolutes. A particle can, without enough energy to climb the wall, simply appear on the other side. It's not magic, it's probability. Everything in the quantum world lives as a wave, spread across possibilities. Even when a particle lacks the strength to breach a boundary, its wave function continues on the other side. And sometimes, yes, just sometimes, the universe allows that possibility to become real. The particle tunnels through. This strange escape is not rare. It happens constantly inside stars, inside machines, even inside your own body. In fact, without quantum tunneling, the sun wouldn't shine. The sun's core is a storm of hydrogen, under crushing pressure and searing heat. Protons try to merge, but like magnets of the same pole, they repel. The energy required to force them together should be immense, and yet fusion happens because those protons, tiny particles governed by quantum rules, don't always follow classical logic. They tunnel through the barrier. They leap the wall, and when they do, they fuse. They release light. The light that warms your skin right now was born of quantum rebellion, of particles ignoring their limits. That light took thousands of years to escape the dense core of the sun. But once free, it raced to Earth in 8 minutes, and here you are, bathed in the glow of something that began with a tunnel. But tunneling doesn't end with light. It lives inside you to dot your cells, tiny engines of life. Rely on reactions that should be impossible without this mysterious passage. Enzymes in your body use tunneling to move protons and electrons through walls of molecular resistance. In the dark quiet of your mitochondria, a spark of energy moves through barriers, feeding you in ways that defy classical chemistry. And then there's your brain. Your brain is not just a static organ. It is a churning storm of electrical fields, chemical gradients, and, yes, quantum effects. Some scientists believe that tunneling may play a role in how your brain makes choices, how neurons fire, how you solve puzzles, feel instincts, dream. Consider this. You're walking, lost in thought. Then suddenly an idea arrives, not step by step, not with explanation, but all at once. Complete. Where did it come from? Some say it tunneled through layers of conscious resistance, through walls of habit, fear, distraction. It appeared on the other side, as if by magic, but it was not magic. It was mind skipping the line. This is how you sometimes leap from confusion to clarity, from silence to song. Your mind may tunnel from what is known into what is possible. And you felt this, haven't you? The sudden understanding, the inexplicable peace, the moment when something felt out of reach then, without effort, was yours. Quantum tunneling is not a metaphor for those moments. It may be their route, but it doesn't always show itself in flashes. Sometimes it is slow and patient. Whisper through the wall. You are surrounded by boundaries, emotional, intellectual, creative. Some you built, some were given. All seem firm until they don't. You think, I can't do that. I don't understand. It's too late. But then something stirs, a quiet push, an irrational calm. And then you try, you learn, you move, and you find yourself on the other side of that thought. Tunneling isn't about denial. It's about possibility. It's about honoring the laws, but listening for their exceptions. In technology, tunneling is a tool. In your body, it is survival. In your heart, it is hope, because tunneling is not a brute force. It does not fight. It flows. It teaches you this, that sometimes when logic says no, possibility says maybe. Okay? And in that maybe, the universe makes room for a miracle. In some of the coldest parts of the cosmos, particles still tunnel. in the hearts of ancient stars. Tunneling keeps them alive. In your own body, it carries energy and thought. What kind of force is that? That obeys no classical rule, yet forms the foundation of so much. It is the power of presence without pressure. The power of being where you shouldn't be, because the universe said you might. And there is another kind of wall. Not in the sun, not in cells, but in time. Sometimes you feel it. The past, like a sealed chamber. The future, like a locked gate. You wonder, can I escape who I was? Can I reach who I want to be? Quantum tunneling says yes, not with force, not with certainty, but with possibility that the you of tomorrow is already forming on the other side of this thought. That when you close your eyes and breathe and imagine you are tunneling, you are stepping into a probability and letting it take shape, not because you forced it, but because the universe allows it. So rest now, and as you drift, let your mind loosen, let it shimmer, let it pass gently through the things that once seemed immovable. And know this, that on the other side of even the hardest wall, it may already be a version of you waiting to be seen, and just beyond that, at the very edges of what time can measure, another mystery pulses, where time itself may slow or loop, and moments are not what they seem. It's time to meet the strange rhythm of time in the quantum world. You lived your days like a string of pearls, one moment beaded after another, threaded along a single line called time, tick by tick. You move from morning to evening, from laughter to silence, from birth towards something unknown. This is how it feels. But what if time is not a thread, not even a river, but a trembling mist? It's folded and scattered across the floor of the universe. What if time does not flow, but flickers at the scale of your life? Time feels firm. Your coffee cools, your hair grays. A clock on the wall tells you what's next. But zoom in past cells, past atoms, past particles that spin and flicker, and you enter the quantum realm, where time loses its grip. Here, time is not a straight line. It is a foam of possibilities. Moments shimmer, overlap, hesitate. A particle might decay after a second, or before it was even formed. A photon might remember the future before it forgets the past. Time, in this quiet place, does not obey the rhythm of your wristwatch. It dances. Imagine a violin string vibrating. Now, imagine that vibration not just in sound, but in time. Moments could rise like notes, echo, return, not chaos, but possibility. Physicists describe quantum systems where particles evolve forward and backward simultaneously, as if reality consults both the past and the future before deciding what the present will be. That's not that time runs in reverse. It's that time, at this scale, does not run at all. It hums in certain quantum experiments. When two particles become entangled, measuring one affects the other instantly, even if they are far apart. Even if one appears to be in your now, and the other ahead or behind. It's as though time can bend. Let two hands meet around a corner you didn't know was there. You might ask, how can anything defy time? But perhaps the better question is, how did we ever come to believe time was so simple? Einstein showed us that time slows down as you move faster, that gravity, massive and patient, can stretch and bend time like taffy. Time, then, is not absolute. It is local, is flexible, and in the quantum world, it may even be optional. Some theories propose that time is not fundamental, till it's a byproduct, a story told by particles as they relate to one another. A pattern, not a law. What you call now might just be the place where your mind finds the most stable rhythm. The past isn't behind you. It is a structure you build, moment by moment. Your memories are not stored on a shelf. They are stitched into your brain's architecture, rewoven each time you recall them. In the future, it isn't ahead. It's a cloud of possible necks, stretching out like fog on a dark road. Yet, even within this uncertainty, you live with rhythm. Your heartbeat, your breath, your waking and sleeping, all move with a tempo shaped by time. So how can both be true? How can time be both soft and sharp, both fluid and fixed? Because you are made of both scales. You are a quantum creature, draped in classical clothes at your core. Your atoms dance to uncertain beats, but collectively, they form a body that walks through life in an orderly pace. You feel time because your brain is built to feel it. Neurons fire in patterns. Hormones rise and fall in circadian tides. Your mind remembers what came before, anticipates what comes next, and that makes the present feel real. But that doesn't mean time is what it seems in dreams. You felt it. An entire story unfolds, full of emotion, movement, revelation, only to wake and find mere seconds have passed in awe. You felt it. A moment stretches, slows, becomes vast like the instant before a fall, or the hush of seeing something sublime. In grief, you felt it. Time stops, or drags, or loops back on itself, pulling you again and again to something that already happened but feels incomplete. All of these are clues. Clues that time, to experience it, is not just a ticking metronome, but a wave that swells and thins within you, and physics agrees. In some interpretations of quantum theory, the equations work equally well, whether time moves forward or backward. In others, the flow of time emerges only when a measurement is made, when potential becomes actual. In these theories, you don't travel through time. You define it, like laying planks on a foggy road as you walk. So, what about time travel? What about the fantasy of stepping backward into a yesterday, or leaping ahead to a tomorrow not yet written? Quantum physics does not say yes with certainty, but it doesn't say no either. In certain solutions to Einstein's equations, loops in time called closed time-like curves appear, and in quantum computing, researchers play with systems that simulate particles traveling forward and back in time. They do not break the universe. They explore its deeper structure. Could your mind, in dreams or insight, be touching those loops? Could memory and imagination be gentle echoes of time's true shape? You don't need a time machine to feel it. You already live inside one. Your brain replays past loves with aching clarity. Your breath slows as you anticipate future joys. You bend time by caring. You stretch it by noticing. You skip it when you stop to wonder. And in sleep, where consciousness loosens its grip, you float outside of time entirely. A single dream can feel like a lifetime. A single night can pass in a blink. You wake and time resumes, but something subtle lingers. The feeling that time is not a river, but a mirror, reflecting back your awareness. So tonight, as you rest, remember this: time is not chasing you. It is cradling you. You are not running out of it. You are floating inside it. Each breath you take is not a moment lost, but a moment formed, and just beyond this moment, behind the thin veil of sleep, the quiet hum continues. That hum, that background tremble of space itself, it's where time may rise from nothing. It's time to meet the silence that isn't silent at all. It's time to enter the vacuum that's full. It's full. You lie still, your body weight pressing gently into the bed, your arms soft against a cool sheet, your breath a quiet rhythm. Around you, the room feels silent. Nothing moves. The space between your limbs, the space above your face, feels like emptiness. But in physics, nothing is never truly nothing. That space, so quiet, so blank, is not empty at all. It is teeming. At first glance, a vacuum might seem like absence. No air, no dust, no heat, no light. Just nothing. But in the language of quantum mechanics, nothing is just another kind of something. A sea of restless fluctuations. A trembling field of probability. Imagine a pond on a windless night. Its surface seems calm, but lean close, and you'll see ripples, tiny, circular undulations, born of insects, temperature, unseen breath. Now shrink that image down past what the eye can see. It's down to the very foundation of space. There, even in the total absence of matter, space ripples. The vacuum isn't still. It vibrates. It jitters. It hums. This hum, known as zero-point energy, is the lowest possible energy that a quantum system can have. Even when all else is stripped away, something remains. A background buzz, a quantum breath. To truly understand the vacuum, you must abandon your idea of empty space as an idle, silent stage. Instead, think of it as a field, not a field of grass, but a fabric woven of invisible forces. Each point in this field contains potential. It can, at any moment, flare into brief existence, spit out a particle and its twin, then swallow them again before you can notice. These are virtual particles, pairs that rise from nothing, exist for a heartbeat, and disappear. They do not last. They are not real in the traditional sense, but their effects are everywhere. Virtual particles have been detected not by capturing them directly, by noticing their fingerprints on reality. In the Casimir effect, two metal plates, placed close together in a vacuum, are drawn toward each other, not by static electricity, not by magnetism, but by the pressure of vacuum fluctuations. Space itself pushes. Or consider Hawking radiation, the theory that black holes can evaporate over time as virtual particle pairs form at the edge of the event horizon. One particle falls into the black hole, the other escapes. Energy leaves. Mass is lost. Even the darkest places in the universe cannot silence the vacuum. Even there, the foam fizzles. And this same quantum restlessness might help explain why the universe expands. Physicists believe that dark energy, the mysterious force accelerating cosmic expansion, may be tied to the vacuum's own energy. The nothingness between galaxies might be inflating the cosmos, not out of violence, but out of the gentle pressure of ever-present potential. Here's a thought. If the vacuum is never truly empty, then you are never truly alone. Even in the quietest moment, when you feel most solitary, space itself vibrates around you. It touches you. It speaks. You are not lying on emptiness. You are floating on a field so intricate, so densely patterned, that we may never fully map it. And yet, your body knows it's there. Quantum mechanics predicts that this vacuum energy should have dramatic effects on reality. And your cells, made of quantum fields themselves, live and move within that frothy hum. Your atoms swim in it. Your heartbeat echoes inside it, and that field stretches infinitely across galaxies, between stars, through walls and wires, and when it is the stage of all things. It's tempting to think of the vacuum as a blank page, but maybe it's more like the paper beneath the ink, always supporting the story, but never read aloud. In the vacuum, there is no matter, no temperature, no time, even not in the way you measure it, but there is potential, and that's what makes it magical. A vacuum can give rise to particles. Its entire universes may emerge from it. Some cosmologists propose that our universe itself may have bubbled up from a quantum fluctuation in a primordial vacuum, from nothing. Everything in this way, the vacuum is not empty. It is pregnant with form. It is the canvas and the paint. It is the silence before the song, and the vibration that begins the first note. So when you feel the hush tonight, the stillness of the air around your resting body, don't be fooled. It is not void. It is vibrating with the prelude of everything. Your own thoughts may feel quieter now, but even your mind floats on this invisible sea. Thoughts arise, bubble up, and vanish. Emotions swell, then fade. In meditation, when you release your grasp on thinking, what remains? Awareness, that field of being beneath all content, beneath all judgment. Perhaps your inner vacuum is like the universe's restless, fertile, and essential. And in the world of science, we are only beginning to touch its edges. The Large Hadron Collider searches for the patterns beneath particles, probing ever closer to the hum of the vacuum. Satellite telescopes scan the cosmic background for echoes of the early universe, looking for signs of inflation, of foam, of fluctuations. Writ large dot, we are listening for the hiss of creation. We are leaning toward silence and hearing something astonishing. And here you are, a creature made of matter, yet floating in field, wrapped in skin in sleep, yet suspended in infinite space. You are not separate from the vacuum, expression of it, an island of form within a sea of formless, and the sea cradles you. It is always there, beneath the atoms, beneath the thoughts, beneath even time itself. It doesn't demand your belief. It doesn't need your notice. It simply is so. Rest. Let your body sink into this trembling stillness. Let your mind ride the gentle hum beneath all things, because the vacuum is not empty. It is waiting, and in its waiting contains all that could ever be. And from that infinite hush, something stirs, a question, a possibility, the beginning of what might come next. You open your eyes to a world that feels certain. It's the lamp on the bedside table. It's the slow creak of the house as it settles into night. It's the steady sound of your breath in the quiet. But if you pull back the veil just a little, you begin to see something softer, stranger, something almost poetic beneath the shape of things. The universe, at its most fundamental level, does not begin with certainty. It begins with possibility. Probability is not just a tool for guessing outcomes. In quantum physics, it is the canvas, the law, the way reality writes itself into form. Imagine a line of words whispered into the dark. Not a sentence yet, it's just syllables full of potential. They could become anything. They could drift into silence or settle into meaning. That's how the universe begins. Particles, before they are seen, exist not in one place, but in many. It's not as points, but as waves, smeared out across the possibilities of where they might be, how fast they might move, what identity they might take on next. These aren't poetic metaphors. This is how reality behaves. A single electron doesn't travel like a marble. It travels like a poem, spreading, drifting, overlapping itself. Its position can't be pinned down until you look. And even then, what you see is just one stanza from an entire unwritten book of maybes. Probability is the language of quantum mechanics, and it is deeply, inescapably woven into everything. Even the structure of atoms, the very architecture of your body, arises from probabilities. The electrons that surround atomic nuclei don't orbit like planets around the sun. They blur, they cloud. They appear as regions where they are likely to be. Your fingertips, your breath, your eyes, all built from these blurred orbits, all shaped by chance. And yet, it doesn't feel like chance, does it? You feel solid. Decay. The cup stays on the table. The moon stays in the sky. The sun rises when it should. So how can the world of shimmering maybes be the same one you live in? Because something strange happens when the universe is observed. The wave of possibility collapses. The poem stops wandering. The particle becomes real. This is known as the collapse of the wave function, a core concept in quantum mechanics. Until a measurement is made, a system can be in a superposition in many possible states at once. But when observed, it must choose. This is not just a theory. It's a measurable effect. Double-slit experiments show that electrons behave like waves when unobserved, interfering with themselves, creating patterns of possibility. But once measured, they behave like particles, choosing a single path. The Universe responds to attention. It's as though reality waits to be noticed before it commits to being real, like a shy artist. It hesitates before revealing its final form, and you, the observer, are part of the poem. This doesn't mean you control reality, not in the sense of magic or willpower, but it means you participate in it. You are woven into the fabric of unfolding. Each time you observe, each time you measure, you shape what is dot. Think of this. The stars you see tonight, their light began traveling millions of years ago, yet only now when you look. Does that light become part of your reality? Until then, it was just a wave, a probability. Now, it is a fact. In this way, the entire cosmos is a field of probabilities waiting to be sung into certainty. This doesn't mean the universe is random. Probability is not chaos. It has structure. It has rhythm, like music, with variations and echoes and themes. The laws of physics still apply. They shape the waves. They guide the chords, but the final note is not always predictable. And here's where the beauty deepens, because even though the universe dances on probabilities, it does so in a way that allows for both pattern and surprise. The atoms in your hand are mostly empty space, yet they don't fall through each other. The sun, a nuclear furnace of incredible violence, rises every morning with quiet devotion. The world is born from chance, but not without grace. And in the mind of a physicist, there is a sense that this probability poem may stretch beyond particles. Some theories suggest that the universe itself emerged not from a solid cause, but from a probabilistic fluctuation, a bubble of energy blinking into existence from a sea of quantum foam. Why this bubble? This version of the laws of physics, this balance of matter and antimatter. No one knows, but the mathematics of the cosmos hints at a truth more poetic than mechanical. It suggests that the universe did not have to be, that it could have been different, that among the infinite possibilities, this one was chosen, or rather, this one emerged because it could, because the probabilities aligned. And here you are, a being made of matter, drifting in space, capable of noticing this fact, of marveling at it, of wondering why it feels so. It's beautiful to be a question inside a question. You are not apart from this poem. You are not just a reader of it. You are a line in the verse. Every breath you take, every thought you think, ripples the probabilities of the world around you. Your presence changes the equation. So as you lie still tonight, staring into the quiet or letting your eyelids fall, remember this: the stars above you, the atoms within you. The silence between them, all of it began as maybe. All of it still carries that maybe. Beneath the surface, certainty is a surface we paint with meaning, but underneath, the world is soft, unfinished, full of paths not taken, notes not played, lives not lived. And isn't that a kind of comfort? That you are not locked in, that the story is still being written, that even now, as you close your eyes, you shimmer across many possibilities. The day behind you fades. The night stretches wide. Somewhere beneath it all, the probabilities ripple, not waiting for an answer, but simply being the question. You've been floating, haven't you? It's drifting gently in the dreamlike realm of quantum possibility, where particles shimmer, where reality hums in uncertainty, where the world is not this or that, but a dance of could be. Now, something changes. It's quiet, subtle, not a crash, not a flame, but a soft unfolding. A breath exhaled. This is the moment a wave becomes a thing. A choice is made, a path selected. A world once smeared in potential narrows into form. This is DECOHE It may sound like a breaking, but it's not. It's a settling, like rain becoming river, fog becoming drop, music resolving into silence. To understand decoherence, imagine this: a single particle, say an electron, exists in a superposition, both here and there, both up and down. A tease. Identity is not fixed. Its reality is not singular. It's not that the electron is hiding something. It's that it hasn't chosen yet. And until it interacts with something larger, a photon, measuring device, a molecule, it continues to drift through this dreamlike space of possibilities. But interaction is inevitable. It's built into the fabric of reality. Particles touch other particles. They bump, they collide, they exchange, and when they do, when a quantum system becomes entangled with its environment, that delicate superposition begins to fade. Not because the wave has collapsed in a magical instant, but because it has been woven into a wider world that cannot hold ambiguity the way the quantum world can. The system becomes part of the whole, and the whole prefers things to be definite. Think of it like this. A violinist playing alone in an empty hall can wander through melodies, pause, shift, change, tempo, hum a half-formed tune. But the moment a full orchestra joins, that freedom narrows. The music must harmonize, a line snap to a shared rhythm. Decoherence is the universe's orchestra, gently insisting on order. It doesn't erase the wave function. It just renders the other possibilities invisible, inaccessible, as if the branching paths still exist, but we can only walk one. This doesn't mean the other branches aren't there. They may persist, faint echoes in a wider multiverse. In our world, they are no longer part of our thread. This is the mechanism by which quantum becomes classical, by which shimmering dreams become the solid cup in your hand. It happens constantly, every time you touch something, every time your eyes open, every time your neurons fire. Your brain is full of quantum events, but the warmth of your body, the noise of your world, forces them into coherence. That's the paradox. Your thoughts might arise from quantum uncertainty, but your mind needs stability to make sense of it all. Decoherence gives us the ground to stand on. It gives the moon a place in the sky. It lets fire be hot and glass be cold. It lets the cat be alive or dead, not both. And yet, what a haunting thing to know that the world once shimmered, that at the smallest scale, everything was still becoming, still choosing, and now it is. This dot, this moment, this room, this breath, a collapsed wave, a song resolved. But listen, the hum hasn't stopped, even in decoherence. Possibility never dies. It hides beneath the surface, ready to rise again. Every particle, every object, even now, is a system entangled with countless others. The dust on your bookshelf is still shaped by quantum fields. The ticking of your watch is still tethered to the rules of probability. Decoherence is not destruction. It is connection. It is what happens when the world becomes aware of itself, when a system becomes so intertwined with its surroundings that it can no longer be described alone. It's like identity, in a way. When you're alone, you may feel many things: joy, sadness, confusion, wonder, all at once. It's undefined. But the moment you step into the world, you play a role. You become something definite to others. You decohere, but inside, you still shimmered so. Too, with the universe. Inside the silence of the wave function is everything. All paths, all songs, all colors. Decoherence simply draws the curtain, lets one scene play, but the script remains. You may wonder, does this mean we create reality? Not quite. We help select the version of it that becomes visible. Our presence, our breath, our observation. These are the threads that help stitch possibility to pattern. Some physicists believe that this is how time itself may emerge. Not as a flowing river, but as a series of decoherent events, each moment branching from the last, cutting away the alternatives, leaving only the path we call now. And that's the magic, isn't it? That now is not just a passive moment. It is the place where dreams become real, where maybe becomes matter. You don't need to understand all the math. You don't need to diagram wave functions or calculate phase shifts. Just know this: when you reach out to touch the world, when your hand brushes the blanket, when your eyes close and your mind wanders, you are participating in the great settling of the cosmos. You are helping the universe decide what shape it takes. Each second is a negotiation, each breath a signature dot, and yet, even with this gentle finality, nothing is ever fully lost. Because in the grand math of it all, waves never truly vanish. They only hide, diffuse, linger, and when you sleep, perhaps your mind floats again into coherence, the quiet state before decisions are made. Perhaps dreams are how your brain remembers that the world was once made of maybes, that beneath your name, your story, your skin, you are still a wave, still soft, still shifting, still becoming. As you drift tonight, know that the world does not harden completely, that even in form there is fluidity. And tomorrow, when you wake, you will begin the soft dance again of observing, interacting, decohering, shaping reality, one quiet breath at a time. Close your eyes. Imagine a soft ripple spreading outward from your chest. Not sound, not breath, but presence. Now, imagine that ripple doesn't stop, that it continues beyond the bed, beyond the room, beyond even the walls of your body. This is not fantasy. This is the quiet suggestion of quantum mechanics. But you might not be entirely here, or more precisely, you might not be only here in the quantum world. The idea of being in a single place is not as straightforward as it feels. Particles, tiny ones, the kind that make up all things, can be in superposition. They can exist in multiple states at once. A single electron might orbit this way and that way. A photon might take both paths. A neutron might spin up and down until we observe, until we ask the question, until we force an answer. And here's the quiet wonder before the question is asked. The universe does not choose. So what happens when the one in question is you? You are made of particles. Every atom, every electron, every grain of your being is ruled by quantum laws. And those laws do not forbid multiplicity. They seem to welcome it. So, in the gentlest voice of physics, we must ask, is it possible that you are in more than one place? Let's take a walk into possibility and experiments with large molecules, thousands of atoms bound together. Scientists have seen quantum superposition. They send these molecules through a barrier with two paths, and both paths are taken, even though the object is larger than an atom. It behaves like a wave until it is observed, till it is known. Now, scale that idea up. If parts of you, the electrons in your brain, the molecules in your blood, can do this, could the sum of you also shimmer across states? Not in the way a science fiction film might imagine, no duplicates running around cities, but in a subtler or poetic sense. Maybe your choices, your thoughts, your memories exist in gentle parallel. Maybe the you who spoke kindly today and the you who stayed quiet both floated briefly in superposition, until one version was chosen by your awareness. The other, it does not vanish. It decoheres, becomes part of the quiet foam beneath consciousness. A physicist might call this the many worlds interpretation. A poet might call it the music of possibility. But the feeling is the same. We are not linear. We are not simple. You might be in two places right now. Not physically. Kari, N-T-I-L-L-Y. In one world, you are reading this slowly. Kara is heavy with sleep. In another, you stopped a few minutes ago, set the device aside, and wandered into a dream. Both are real. Both exist, but only one becomes your path. And even then, the other leaves a ghost, a whisper, an emotional echo. That's why sometimes you feel pulled in opposite directions, as if two versions of you are having a conversation quietly beneath the skin. The philosopher in you wonders, If I had chosen differently, would I still be me? The quantum physicist might smile and say, you did choose differently, somewhere, somehow, and in that world. You are walking another road. So much of your daily life relies on solidity. Where are your keys? What time is it? Teed, I say the right thing, but beneath the routines, beneath the ticking clock, there's a shimmering, a hum of uncertainty, a gentle question that never quite resolves. Where are you? Not just in space, but in possibility. This is not meant to unsettle. This is meant to soften, to loosen the grip of certainty. And let your thoughts become clouds for a while when you remember something that never quite happened, a conversation that feels familiar but has no place. Perhaps you are brushing against the walls of another you, a self just slightly adjacent, a path just slightly offset, and when you feel an intuition, a decision that rises like a wave, perhaps, it is the result of all your possibilities coalescing into a moment of clarity, your superpositions collapsing into the version of you that must now act. You are not merely here. You are not merely now. You are an unfolding pattern of choices, collisions, and contemplations. You stretch through time. You echo through chance. There's a comfort in that, isn't there? That your mistakes do not define you, because they're only one version of a much wider self. That your regrets are just shadows cast by paths not taken, yet still part of your story's shape. That your kindness exists, not because it was inevitable, but because, in a sea of maybes, you chose it. That your love is real because it rises above the quantum noise and becomes a signal. You might be in two places, right now, but one of them is here, breathing, listening, sleeping, and the other, maybe, is dreaming of this one. Maybe it's holding the memory of a lullaby you've only just begun to hear. The chapter ends, but the shimmer does not, because next we ask something deeper. What are you made of, if not all the maybes the universe still dreams of? Close your eyes and feel your weight melt into the bed. Feel your chest rise and fall like the tide, like a planet breathing. Now drift, not outward, but inward, toward the soft mystery that is you, not the name, not the role you play in the world, but the quiet pattern of being that pulses beneath all of it. You are made of atoms, yes, carbon and oxygen, nitrogen and calcium. You are made of stardust, they say, and that is true. But even more than that, you are made of silence between the particles. You are made of space. The atoms that make your body are not tightly packed marbles. They are mostly emptiness, a nucleus in the center, and far, far away, an electron cloud, shimmering with possibility if you were to scale your atoms up, so that the nucleus was the size of a golf ball. The nearest electron might be several kilometers away, and in between, nothing or not nothing. Something softer, quantum foam, fields, fluctuations in that quiet space. The whisper of identity begins. You are not a statue. You are not a fixed thing. You are motion, always in motion. Even in stillness, your blood flows, your cells renew, your thoughts pulse like auroras in your brain, and even that brain, itself a galaxy of patterns, doesn't always know what it's doing next. The moment before a thought arises, where is it? The breath before an idea comes, what shape does it take? Sue is mystery. Scientists can measure neurons firing, can map brain waves, can predict outcomes with percentages, but they cannot yet predict you, because you are not just chemistry. You are the poetry that happens between the chemistry. You are not the electricity. You are the song the electricity composes as it dances across your synapses. You are not your heartbeat. You are the rhythm of memory that beats inside of it. So when people ask, what are you? They expect a simple answer. You are a human. You are a collection of cells. You are a name, an age, a history. But deeper still, you are a shimmer in probability. Self that could have taken many forms, and somehow chose this one. You've likely heard the phrase, the universe observing itself. It sounds grand, but it's not metaphor, it is literal. Your eyes are made of matter that once swirled in nebulae. Your brain is made of carbon, forged in dying stars, and now those atoms think, they feel, they wonder about themselves, they fall in love, they remember pain, they listen to music and cry at sunsets, all while still being part of the physical world, subject to gravity, to entropy, to time. You are a paradox that science does not fully explain, because while we understand the pieces, the molecules, the charges, the genes, we do not yet understand how they become you. Consciousness is a mystery, not because it is magical, but because it is vast. It's like trying to explain a symphony by listing the properties of a single violin string. The mystery isn't that the string vibrates, it's that it can create grief. It can summon memory, can sound like forgiveness. And so, here you are, a symphony of molecules, humming softly in the dark. Not perfect, not certain, but real. The quantum world whispers through you every moment. You are built on uncertainty, but walk through life as if on solid ground. You make choices without knowing all outcomes. You love without guarantee of being loved back. You hope in the face of entropy. This is not weakness. This is wonder. You contain particles that once belonged to trees, to oceans, to people long gone. You contain water older than the sun, and when you speak, your voice stirs the air, vibrates molecules, carries heat across a room. Even your silence moves the world. If someone sits near you in stillness, they are touched by the energy your body gives off, by the rhythm of your breath, by the gravity of your being. You are not separate. You are woven into fields of probability, into the pulse of the planet, into time itself. So when you lie in bed at night and wonder who you are, know this: you are not your worries. You are not your failures. You are not even your thoughts. You are the soft awareness beneath all of them. You are the still lake under the ripples. You are the space between the stars and also the fire that birthed them. And when sleep comes, as it surely will, it is not a pause in this mystery. It is a deeper entrance, a slipping beneath the surface into the quantum sea, where time bends, where you travel without moving, where self and not self blend like waves in dreams. You return to the place before thoughts. You float not in emptiness, but in possibility. Your brain, even in rest, is a light with motion, reviewing, rewriting, rebuilding, and somewhere in that gentle fog, you may glimpse it not an answer, but a feeling that you would never separate, that the world is not made of parts, but patterns, and you are one of them, not the loudest, not the largest, but essential. The universe hums through you, and you are listening, even now, even as you let go, even as your breath slows, your mind quiets, your awareness becomes soft as mist. You do not vanish when you sleep, you become more diffuse. You stretch across dream and memory, across time and biology, across 1,000 forgotten stories woven into your skin, and perhaps, in that space, you hear the quietest truth, that you were never alone, that you were never simple, that you are, and always were, a soft mystery in the universe, ancient, wild, certain dreams of itself by dreaming of you. So rest now, let the quantum foam beneath you cradle your bones, let the silence carry you. You are here, you are everywhere. You are exactly enough, and the story of the cosmos continues in you, in you.